Nicole Patterson, and today I'm going to show you how to do an SDS PAGE experiment. To start this experiment, we're going to do our sample prep. So we're going to prep our samples to load them onto the gel plate. For the sample prep, we're going to need 2x SDS buffer. This will help denature our samples. I also have bovine serum albumin, which we're actually going to run on the gel, as well as a stage 3 enzyme that we isolated from alkaline phosphatase. In addition, we're going to have some Eppendorf tubes that we're actually going to put our samples in. We're going to heat them up at 95 degrees using this hot plate. You'll have 2 sets of micropipetters and P200 micropipetter tips. To prepare our samples, I'm going to micropipette 30 microliters of our enzyme that we isolated from E. coli and 30 microliters of our alkaline phosphatase into separate Eppendorf tubes. And then to each tube, I'm going to add 30 microliters of our 2x sample buffer, and I'm going to mix them well. All right, so I'm going to use my P200 micropipette, and I'm going to set it to 30 microliters by turning the knob. Takes a while. It was set at 200 microliters, so just be patient. All right, so we are at 30 microliters, so our P200 reads 030. All right. Next, I'm going to take these 2 clean 1.5 ml Eppendorf tubes, and I'm actually going to label them at the top. It's always important to make sure you label your Eppendorf tubes and other tubes in the lab so that you don't mix up your chemicals. So I'm just going to label one of them E for enzyme and the other one B for BSA. Something that I'm missing right now is a container to dispose my pipette tips. So I'm going to put this one to the side because we're not using it. Again, even though I set it at 30, I still confirmed since I walked away for a second. So to load the tip, I'm going to press the pipette firmly into the tip, and I always knock it just to ensure that the tip is on there correctly. So first, I'm going to take my enzyme. So again, double check. Going to go straight into my solution about halfway down and slowly release the top. I visually inspect the tip to make sure that it looks like there's about 30 microliters in there. And now I'm going to slowly release into the bottom of my Eppendorf tube. Since we are using a different chemical, I'll have to get a new pipette tip. So I make sure it's still at 30 microliters. Again, I'm going to go into my solution and slowly release the tip. Now I'm going to go into my Eppendorf and again, slowly release. Make sure that everything has come out of the tip. Now I'm going to add 30 microliters of our 2x buffer to each solution. All right, so I'm going to go in and I'm going to release my solution, but not take my pipette out because I'm going to mix by pipetting up and down 10 times. This ensures that your solution and your dye come in contact with each other. All right, a new tip, since we are going into a new solution. Again, I'm going into my solution, pipetting up and down 10 times to ensure that everything is mixed. Now our samples are prepped. We're going to heat them at 95 degrees for 5 minutes to ensure completion of reaction. Now that 5 minutes have passed, we can get our samples off of the heating block. And now the next step is to load the gel. To do that, we are going to use some very special gel loading tips. I'm going to show you the tips that we previously used. They're about this size. The SDS plate is very thin, which I will show you in a sec once I open it. And so in order to actually load the samples, we need very thin tips like this. So we're going to use these gel load-in tips, which I'm going to put to the side. We are going to load our gel in here and form a sort of dam, which we will eventually put in here once we set up the SDS apparatus. Our SDS gel comes in this packet here. We're going to open it up. And this is actually the gel plate. So you can see it's very thin, which is why we need those thin pipette tips. The plate has two components that need to be addressed before you start. The first one is the comb at the top, which actually keeps our wells in place. We'll be loading into these wells. It also has green tape at the bottom. It is imperative that you remove this tape, because if you do not remove the tape, electricity will not flow through your plate. All right, so I'm going to first remove the tape, put it to the side. Then I'm going to remove the comb at the top. It is in there very firmly. We want to remove it, but we also want to make sure that our lanes are still in place. All right. When we run the gel, we have to form a sort of dam so that we can put buffer in the middle, which helps the samples run down the gel. So I'm going to take this new plate that I have. Our plate has a high front and a low back. So I am going to put the plate in here with the high front in the front of the plate. See, when you do that, you can read the gel lanes 1 to 10. However, I do need to form a dam, and so I'm going to use an older plate in the back to help form my dam. All right. So now I have both plates in firmly, and I'm going to close this up. I'm going to put some buffer here in the middle to make sure that the dam is not leaking. All right, so this is the buffer that we had previously diluted. Just going to pour a little bit in here to make sure that there are no leaks. Yep, looks great. If there are leaks, it's okay. You can always open this up. You can let the buffer fall in here. It's all right. And then re-secure your plates. The very cool thing about our SDS apparatus is that it's color coded. So here we have a black probe and a red probe. Then if you look in here, there's a black side and a red side. So we're going to put black on black and red on red. I'm just going to fill this dam all the way up with buffer. Now we're ready to pipette. I'm going to pipette in 10 microliters of our molecular weight ladder. This will show up as different bands that correspond to different molecular weights. So I'm going to set my P20 micropipette to 10 microliters. This will go in lane number 1. So I have this set at 10 microliters. I'm going to open this up. Ensure that the tip is on there firmly. Now these tips are very low retention tips. And what that means is when you pick up your liquid, it does not all go up at the same time. So you actually have to wait before removing your pipette to make sure all of the liquid has gone into the tip. So I'm going to go down. Now I'm going to show you two things. I'm going to show you what happens when you remove the pipette tip too quickly. This happens. You don't get all of the liquid or all of the chemical. So whenever you're using these low retention tips, go into your solution, you slowly release, and then you wait about 5 seconds to make sure that all of the liquid has actually gone into the tip. To load this gel, we're going to load between that plate and that very thin space. So I like to use this hand as the one that will release your liquid, and this hand I use to help steady the tip. So what I like to do is I find my lane, which is lane number 1, and I go up against the front, which is the high part, and I slowly go in. Once I am in that well, I slowly move my pipette back and forth like this to ensure that I am actually in the well. It's really easy to think that you're in the well when you're actually in the center where the buffer is. I'm going to slowly go along the side of the taller part. Then I gently move my pipette. I'm there. I'm going to go near the end, but not right at the bottom of the well because we don't want to poke a hole in it. And I'm going to slowly release. Slowly release. And now everything's out. I'm going to slowly lift my tip up. It's important to release slowly here. If you go too fast, all of your solution may come out of the well and go into another well. All right. Now I'm ready to add my enzyme and my bovine serum albumin. We want to add 30 microliters to each well. These tips only go to 20 microliters, so I'm going to add 15 and then 15 again. I will change the tip every time. Even though we are putting the same solution in one well, I'm still going to change the tip because it's going to get contaminated with buffer. You may need this later on. I'm going to skip a couple wells. Whenever you're running this assay, see how many wells you actually need. If you can, at least skip the first well, and that's to make sure that in case your ladder spills over, it doesn't go into your second well where you have a chemical that you might want to investigate. Your ladder will show up as every band in that well. So we'll try to skip at least 1, maybe 2 wells. In this case, I'm actually going to use well number 4 and well number 8. All right. So our enzyme is going to go into well number 4. So I make sure everything is there. And again, I'm going to go in down the side. I'm near the bottom, but not touching it. Going to slowly release. And I'm going to do it again. All right. And now I'm going to go into well number 8 with our bovine serum albumin. I ensure that I'm actually in the well. Slowly release. All right. And we are good to go. We've loaded our wells. Now let's finish setting up the rest of our apparatus. So this apparatus is actually capable of running 4 gels. We're only running 2 today. So I'm going to fill it to the line that says 2 gels with buffer. So I'm going to top off my dam. And I'm just going to keep adding until we get to the 2 gel line. Excellent. Next, we're going to attach the power supply. So again, red on red, black on black. I'm going to plug in my power supply. And I'm going to set this to 220 volts. So first, you put this on. Okay. I'm going to set it to 220 volts. We're going to plug in our probes. We're going to set this to 200 volts, and then we're going to hit this little running man to start. And if it works, we should see bubbles going up, which we do. So we're going to monitor this to look at the dye front going down the gel, but we'll probably stop it in about 45 minutes. So it's been about 40 minutes, and we can see our dye front has reached to the bottom of the gel. And so now we are going to stain our gel. So I'm going to turn this off. It's going to make the running man stop. I'm going to turn this off. And I'm going to remove the power supply. Now this will feel a little warm as expected, but it's not hot enough to burn you. So I'm going to open up our dam and remove our plates. On the plate, you can see the ladder clearly marked, but you cannot see the 2 other proteins that I ran. So we're going to stain it with some dye. I'm going to actually just rinse this plate really quickly with some deionized water. I just ran some water over this plate. Now I need to get my gel. So what I'm going to need is, we're going to use this tip box to actually put our gel in. We're going to use this spatula to break the plate. And we are going to use this Comasi blue staining solution, which will actually stain the proteins that we've run on this gel. Now your plate has 4 different places where there are arrows. All right, you can see arrows here, all along here, and all along the side and here as well. This is the point or the part where you can actually break the plate Now, I suggest breaking near wells that you haven't used. So I'm actually going to break at the bottom near well number 10. And that's simply because I know that I haven't used that well. And if I accidentally damage the gel right there, it's okay because there are no proteins in that area that could be affected. I'm going to start there as a practice near well number 10. I'm going to insert this and then break the plate at the arrows. All right, so now that I've broken the plate at all the arrows, I can remove the top plate and you can see the gel on here. It is very thin, so be very careful removing it. It's very easy to rip. So again, I'm gonna go over near lane 10 where I know I didn't have anything, and I'm going to slowly and gently lift the gel off the plate and then get it in here. Now, once your gel is in here, it will bunch up like this. Don't worry about it. Don't try to move it with your hands because you will rip the gel. Instead, once you put your Kumasi blue stain on it, you can move it around and the gel should flatten out by then. So we're going to open this. And now I'm going to get my pour enough Kumasi blue in here to actually cover the gel. And you can see that once I move it around, the gel has now flattened out. So I didn't need to use my fingers to move it. We're going to leave the Kumasi blue on here for a couple of days so that it can stain properly. So I'm going to cover this with some cling wrap, label it, and leave it in the hood for a couple of days while it stains. And then afterwards, I'm going to de-stain the gel. Here's the gel in Kumasi blue. I'm going to cover it with some plastic wrap for a few days, and then we will de-stain any unbound dye. So we let our dye stain our gel for 4 days, after which I added some de-stain solution, which is a solution that will remove any dye that's not bound to any protein. And it's been sitting in de-stain solution for about 3 days. We can see that our gel is pretty clear, but I'm going to put it on this so you can see it even clearer. Again, it's very thin, so we have to be careful when we remove it. Here you can see on our gel, we have our ladder, still pretty clear. We have a very faint band here, which is the protein that we had isolated in the lab. And we have 2 major bands here from our bovine serum albumin. So this is what the gel looks like once it's de-stained.